Hey folks, let's graph a cosecant transformation. First thing we'll do is find the guide function. The guide function is just found by replacing cosecant with its reciprocal. So the guide function will be y equals 5 sine. And while I'm doing this, I'm going to factor out the 1/2. You don't need to factor out the 1/2, but factoring out the 1/2 allows us to see the phase shift really clearly. So I'm going to factor out the 1/2, and 1/2 comes out of pi, leaving 2 pi. You can always double check that your factoring is correct by doing the distribution back. 1/2 times x, 1/2 times 2 is 1, so that will create a negative pi up there. And I like doing that because now I can see that the phase shift is 2 pi. You can also do the negative c over b thing, this divided by this. That will give it to you also. But I like this because it makes it transparent. Reflection, no. There is no leading minus, no reflection. Amplitude, absolute value of leading coefficient. Period. 2 pi for a basic sine, and then we have to divide by the leading coefficient of the angle right there. Period is 4 pi. Phase shift, 2 pi. Opposite of what we see after we factor. We see a minus 2 pi. Phase shift is opposite of what we see. Vertical shift, exactly what we see. All right, let's come over to the graph. We always, for sine and cosine, start at the phase shift. So the phase shift is 2 pi. So we're going to call that 2 pi right there. We'll say that that's 2 pi. And the period is 4 pi. So we have to add 4 pi. And that will bring us over to 6 pi. Now again, you could just make an inequality and put this between 0 and 2 pi. And that would give you these same endpoints there. So either way, we need to get the left and right endpoints. Now we're going to look at the vertical shift. The vertical shift is down 2. So that means that our center line is right here. Now we're graphing a sine. So let's take a look at the basic sine. So a basic sine looks like this. That's what one period of sine looks like. Here are the key points. Here is the center line right through there. Okay, next we need to graph our key points. Now we need to keep in mind that our amplitude here is pretty big. It's 5, so we need to go up and down 5 from that center line. So there's 2, 3, 4, 5. It's going to be a little bit stretched out. 1, 2, 3, 4, 5. Okay, now there is no reflection, so our key points will be just as we sort of see them here. 3 in the center. So 1 at the, whoops, let me see if I can click undo, get that to go away. Our key point should be right at 2 pi, so right there. Another key point at 6 pi, and then 1 dead center. And then up on the left, down on the right. So on the left, we're going to go to 3 pi and go way up to here. And on the right, we're going down, way down to here. So yeah, I'm going to be able to graph this well, aren't I? So here is our guide function. And now if we want to graph our cosecant, we need to put in our asymptotes. And our asymptotes are where the graph crosses the center line. So right there is one asymptote. And for cosecant, we are going to see that we have 3 asymptotes for this first period. So wherever the guide function crosses the center line, we have asymptotes. And then we fill in the curves. So here we have a nice clean upward opening curve, and down here we have a nice clean downward opening curve. Remember that it's trapped by these asymptotes. So there is a picture of period 1, also referred to as the primary cycle of this cosecant transformation. Let's finish it off for good measure by talking about the domain and the range of this function. The domain, all reals except the asymptotes. And if we look over here, our first asymptote is at 2 pi. So x cannot be equal to 2 pi plus the distance between consecutive asymptotes is 2 pi. So plus 2 pi k. And k is an integer. Now what we notice here is that, oh gosh, the left if we keep going to the left, the next consecutive asymptote to the left is actually right at 0. So you could rewrite this as x not equal to 2 pi k. So if we wrote it this way, this first asymptote that I've drawn to the left of the first period would be when k is 1. But if we leave it this way, this asymptote on the left side of the first period would be when k is 0. So k is an integer, -2, -3, -4, +5, +6. So there's going to be an asymptote for every integer times 2 pi. So either one of those, totally acceptable. Could you have put 6 pi plus 2 pi k? Sure, why not? You could put 6 pi plus 2 pi k. You could also put 4 pi plus 2 pi k. The cleanest would be just x equals 2 pi k. But any of those are correct. It's just that the asymptotes would be graphed for different values of k. The range, what are the y values that this function uses? Well, way down -infinity, and we come up to that point where it stops. And that point is, let's see, there was -2 from the vertical shift, and then the amplitude was 5, so we're down here at -7. And we're including that -7, so we use a bracket. And then there's no y values in here, and the y values resume up here at 3, because that's -2, the vertical shift, plus the amplitude, so we add 5. So we're going to resume at 3 and go forever up. So that would be the range. All right. Hope that makes sense. Hope that helps. Good luck.